Good day, everyone. In this video, we're dealing with the rest of the semester. That means that we are at the last lesson. Yay! It is done with, it is over. This is the last lesson of the semester. In this lesson, you're going to be dealing with graphs of sine and cosine graphs. And of course, to achieve that, we have to do some polynomial review and some trig review. Everything that you have been taught from the beginning to now has been connected. Alright? I know many of you guys feel like it's always something completely new. That's not the case. You're using the old material that you have learned to address the new material. Alright, reminders. Y'all, the school tutor has ended, so there's no more of that going on. No more. I'm available second block on A day and fourth block on B day. But in order to come to my classroom, I have to have documentation. If I do not have documentation from your teacher, I cannot allow it. I could, write no asking them, can they? But I have to have documentation for them saying, yes, I give you permission to be up in my class. So keep that in mind. If you don't have it, I don't want to see you. Use these videos for review and to work problems accordingly. So you guys, almost every time where I fail, you guys tend to do poorly on tests. And many of those questions come straight from the video. About 80% of my test questions come from the videos. I need for you guys to watch them. Alright? If you have not done so, subscribe. They give you a few bonus points. Make sure that your notifications are on too. So therefore you can get anything that you need. You get what you need so you can be ready for your, mastery of test. Even if your behavior is whack, because some of you like to, just a few of you like to be so out of pocket to a point that you miss stuff. Well, when that happens, it falls to you, not me. You are responsible for your lesson, not I. My job is to give it to you. So even if you don't listen to it, as long as I give it to you in some form or fashion, even if you didn't get what was being said, I did my job. Announcements. So this is going to be a unique situation how we've been getting, how this semester is going to play out. So you have one lesson, which is the lesson that I'm going to deliver, then some review, then a unit test. Your last test, and this is before midterms hit, is December 4th and 5th. Some ACT topics will be included on the test. After the test, then we will review for midterms. You must keep up with your education, not die. So if you're not here and you choose not to use your phone, get Google Classroom, or get to these YouTube videos that I work so hard on, falls to you, not to Howard. So please be about your business. Being absent for no reason does hinder academics. So if you choose not to go to school because you just don't want to be fooling with nobody, that's one thing. But you choosing not to do work either while you at the house, well, that's gonna be an issue that's gonna cost you. Bring notices upon return or suffer the consequences. Don't come back to school thinking your grade's not gonna be hindered if you have not brought notices. Alright? Any work that was assigned before Thanksgiving break and was not completed before Thanksgiving break, you have a 0. And I'm not giving you no makeup. And I know you could say, oh, Miss Howard, I was gone for this period of time. That's fine, but you didn't communicate it to me. Alright? So if I don't get the memo, I can't verify it. It's one thing to show your attendance to the school, but I, as your teacher, have to know what's up so I could help you. So if you're not sending me messages or doing the work from your house, can I give you a grade? Alright, if approved, you can take missing test or quiz. There's the ACT thing we did, quiz, and then there's a test that some of you missed. If I approve you to do so, you can, but if you choose not to, or you miss days and not even spoken to me about, guess what? It's against you. Exemptions. We are getting close to getting exemptions, handed out to kids. After passing my last test of the dates that I mentioned, if you have a 93A after that, you are excused from my midterms. Or if you have scored an 18 on the Math Official ACT, you are excused from any of my tests after you have shown your official Math ACT score. I'm not talking about the practice, I'm talking about the ACT that you went and would take on December 9th. Some of you. And then the only two exemptions you have. I'm not looking for an 88B. If you don't have a 93, I'm not looking at you. Last test before midterm. So this is what's going to be on your test before midterms. Alright? Now, I know many of you guys bombed my other test and you asked for a retake. Well, pass this test and I will replace your other test. So let's get this one out the way. These are the topics. Pause, take notes. Alright, I assume that you did pause the video and you took notes on what you needed to know. So let's move on. Alright, review of polynomials and their graphs. Alright, so let's talk about the domain. The domain, it deals with all the x values, and of course x values are all horizontal. So when it comes to this particular problem, you notice that this problem has arrows. So on the left hand side horizontally, it has arrows, and then on the right hand side, it has arrows. But when we think of x, if x is on the left hand side, it's negative, right? And because it has arrow on the left hand side, it just means it just came from a very, very small number. So we don't know what that small number is, so we always say infinity could come from a very, very small number. It could be negative gazillion, negative trillion, anything like that. But as we go to the right, we notice that the graph also has an arrow there too. And so that means that the graph keep going, does not stop. And so therefore the domain of that is going to be positive infinity. Another way of saying this is because it's coming from both negative infinity and positive infinity, you could say all real numbers. Alright? The range. the range is going to be going from down to up. It's going to be your y values. So when we look at this graph, it starts off around -30. But as I go up, I see an arrow, and that means go to positive infinity. So -30 to positive infinity. You know, because it's negative, or anytime you're dealing with a number, you're going to use brackets instead of parentheses. But we will talk about that more so as we prepare for midterms, because this is something I want you to know about as you prepare a review. And you've seen this before in Ms. Myers' class, and you saw this in Algebra 1. So where are the zeros at of this graph? -3, -1, and 2 are your zeros. So -3, -1, and 2. Give me your zeros. Where are your factors at? So if your 0 is -3, your factor is going to be x plus 3. Now, we got to think about the multiplicities. Well, because you just go through your graph, you just go through your graph like a slice, it has a multiplicity of 1, or you could just say no multiplicities. So if your 0 is -1, well, your factor is going to be positive 1. But you see how it lays flat at 1 and then rises up? That means that it has a multiplicity of 3. And then we say that the 0 is positive 2, right? Well, it's going to be x minus 2 for the factor. But the graph bounces, so it's going to have a multiplicity of 2. So let's look at the local and absolute maximum. So your local min is when x is 0, or when x is 2, sorry. But your absolute max, because you got infinity going on, your absolute max is going to be infinity. Alright? So my local max, I'm just looking for hills. So that's going to be where x is. Just 1. But my absolute min is going to be when x is at -2. So y'all don't forget, when I say absolute max, I mean the highest point of the graph, which was infinity. And when I'm saying absolute min, I mean the lowest point. When I'm saying local max, I'm looking for a hump. And the hump was at when x was 1 for max. But for the min, it was when the x was at 2, and that's local. Again, local, not absolute. Alright? Alright, my people. Let's proceed on. Alright, in this one, I want you to try this one on your own now, since you got a little bit of remembrance of this. So, pause the video. Well, you don't have to pause the video. Don't pause the video. You're going to do this on your own. And then, if you see me in class, just come talk to me about it. Alright, now I got to make sure that you guys know how to factor. Factoring is critical. I'm gonna get you started, but I want you to know how to finish this. Because of course my test, every test that we do, well, with the exception of that one, but for this test, I gotta make sure that your factor skills are much improved. Cause we factor a lot. I'm gonna say, Erica, who? You have did a factor. So, factor. Before you factor your trinomial, what's the greatest common factor of all these numbers? Yep. Your greatest common factor is going to be 3. So when you take 3 out, what's going to be left on the inside? X squared. So 3 times what gives me negative 24. X. Negative 8x. 3 times what gives me 45. Plus 15. Alright. I got you started. Now you're going to finish it. But please keep in mind, you, on your next test, you're going to have to learn how to do all that yourself. Alright, so let's go ahead and do our trig review. Because for today's lesson, we have to have some type of trig knowledge. Alright, so this is a basic 45, 45, 90 triangle. Find the missing side of this triangle. Now, I know I did not put this on the test. Well, I did, but I put it in such a different way. I presented it very differently. I presented it like the worksheet that you did in class with the table. But here, look at it. So we know that for 45, we know that the two legs are going to be similar. And we know the hypotenuse is the leg length times the square root of 2. So we know that that's 7. So that means both legs are going to be 7 here. And that's just using your properties of trig. Okay? And that's just that. It's not hard, nothing crazy. But you would need to practice this a lot. And I'm going to show you, I'm going to give you some practice. It's going to be including the cahoots and all that stuff. Alright, so this is a 30, 60, 90 triangle. I need for you to give me the missing size of it. So we know, if we look at it, we know that the adjacent leg, which is 7, is your short leg. But we gotta know the opposite and the hypotenuse. So we know the hypotenuse is twice the short leg. So if I double 7, I get 14. The long leg of this is going to be the short leg times the square root of 3. Alright? And I just know this from laws. If you're struggling with the 30, 45 special triangles, again, please refer back to old videos that we have already did with this. Again, this is nothing new. This is just taking connections from pieces to moving on. Alright? I look like I rewrote everything, so let me clear it out. So there. Alright. Let's see what you can remember about these particular special triangles. Now, these are very similar to the triangles we did, but we're breaking them up to get to the unit circle. So the first one, pause the video and just try to think of it. What kind of triangle is it? Is it a 30-degree triangle? Is it a 45? Is it a 60? Take a moment to pause and try to answer all three. Alright, welcome back. So let's assume that you have figured this out already. So we know that the first one is going to be 30 degrees because we know that 30 degrees has the long leg as the adjacent, which we know that the adjacent is your x value. And that leg is going to be the long leg. And then over here, this is your short leg. And that's going to be your y. So your opposite I'm trying so hard to write this. Your opposite is your y, which is your short leg. And then we know that your hypotenuse, and we know that the hypotenuse is the radius of the circle. So we know what they are for a 30 degree, and we know that at 30 degrees, the shortest leg is the one that is the opposite leg, not the adjacent. So with that being said, let's move on to the other triangles. Well, we know that the second one is going to be 45. And we know that because we look at the triangle, the short and the long leg both look equal, have the same amount. And we know that the hypotenuse is going to be the square root of 2. I shouldn't have told y'all that, but I gave it to you. Alright, and we know that the last one here is going to be a 60-degree triangle. And we know this is going to be a 60 because your long leg is now your opposite leg. Your long leg is your opposite leg. Your long leg is your opposite leg. Now, with that being said, let's go get the trig ratios for each part of this triangle for all three. So, when we're looking at the 30 degree, we know that the long leg, well, start off with the short leg, my bad, is going to be 1. The long leg is going to be square root of 3. And then the hypotenuse is going to be 2. Alright? And that's just for a 30-degree triangle, not 30-60, a simplistic 30-degree triangle. So let's look at the 45. we know 45, they both gonna have the same measurements for the legs. And we know that the hypotenuse is gonna be square root of 2. Now, we know that 30 degrees or 60, it just flips the leg of a third degree. So that means that the long leg is square root of 3, and that is now your opposite leg. And your short leg is just 1, and we know that the hypotenuse is the same as it is for 30 degrees, which is just 2. So what I need for you guys to do is now give me the 6 trig ratios of each triangle. Again, pause this video and give the 6 trig ratios. Alright, it is assumed that you understood the instruction. If you have not, I'm going to repeat it again. I want you to work these out. For each triangle you see, I need all 6 trig ratios for each triangle. So if you have not done so, pause the video and try it. Alright. Did you do all of them? Well, I hope you did, because we have did these triangles already. I'm not going to do all of them. I'll probably, write in one or few of them. So for 30 degrees, if I was to do sine of 30, I know that's going to be just 1/2. I know if I wanted to do tangent of 45 degrees, I know that's just opposite over adjacent, which is just 1. And to understand sine of 30 degrees, I went opposite divided by the hypotenuse. Now, cosine of 60 degrees is just going to be 1 over 2. Now, I didn't do all 6 for each triangle, but I want you to do that, because that's going to help you with the next thing that we're going to do. Alright, you're going to use the knowledge that you just did with that triangles, and you're going to find the outer part of the unit circle. That's how the unit circle is created. And remember, in case you have forgotten, x and y are no longer your values. They are cosine and sine. But keep in mind what's going to be positive, what's going to be negative in whatever quadrants you are in. And do not forget, tangent is made from sine over cosine. I need for you to keep that in mind. And that's all you need to, have a good understanding of. So you could do this next part. Alright, so let's prove all the facts for 150 degrees. Well, I know the radians of this, the 150. The radius of 150 is 5 pi over 6. So I do know that off the bat. And I also know if I look at that denominator is 5 pi over 6. and 6 being the denominator, I know something about that in terms of the reference angle. So pi over 6 has a degree form of 30 degrees, and therefore the reference angle is going to be 30, because also you subtract 180 minus 150 because you are in quadrant 2, and you get 30 degrees. Alright, the next thing I know is the following. I know cosine of 150, because of its reference angles being 30, is square root 3 over 2. But because cosine is in quadrant number 2, it's going to be negative. And I know cosine of 150, which is essentially saying 30 degrees, is 1/2. But because it's in quadrant 2, it's going to remain positive. Alright? Let's see what effects can we recall. To find tangent of 150, all I had to do is go sine divided by cosine. So I know sine of 150 is 1/2. And I know cosine is going to be 3/2, but when I divide that, it's keep change flip. It's going to be 2 negative 2 square root 3. And when I multiply those 2's out and I rationalize the denominator, I get negative square root 3 over 3. Now, I know I did not show my work from here to here, but I need for you to figure that out. I told you how, but I need for you to work the little details out between there. Again, you can never ever, forever, ever, 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 ever have a square root in the denominator. You can never ever, forever, ever, never, ever, 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 ever have a square root in the denominator. Alright? And you, not me, gotta find those trig inverses. You gonna have to do that. On the test, instead of me just asking you a simple question, I gave you a table to fill out to do all that unit circle. Many of you guys, for some reason, it just didn't click that you had to do that. And I had to fill out any missing details that I left out on purpose. Alright, trig graphs. Sine and cosine periodic functions. So listen up. You're not going to be worried about tangent because I told you tangent is not a true trig function. Tangent consists of sine over cosine. But we call these two sine and cosine graphs periodic functions because they never stop rotating. So if you visit a loved one in the hospital and you see about their heart rate, it looks something like this. The heart rate looks something like this. You want to keep going and keep going and keep going. As long as it doesn't flatten out, it's a good heart rate. So that's why we call these a periodic function. Alright. I'll show you how to do this in Desmos. This is just showing you what you will be doing in Desmos. So don't freak out. I got you. Alright. So these are definitions that you may want to write down. So the period, because there's so many parts of a trig function. The period goes from one peak to the next, or from any point to the next matching point. Now, I ain't gonna lie to you. Even when I was learning trig, I hated the period because to me it was hard to understand because math teachers don't really give the good definition of a period. And that definition is not my favorite, but I'm gonna show you how to do better about that. The amplitude is the height from the center line to the peak, or we can measure the height from the highest of the point and we divide that by 2. I don't think you won't have to worry about all that, but we'll see. Alright, phase shift. And just to let you know, I put those pictures in. They came from a good website that you may want to look into. Math is fun, and they literally will help you out. So go check their sources out. A phase shift is just talking about how the graph moves from left from right. Vertical shift is talking about how it moves up and down. Again, you guys did this in geometry, so you guys know what's up. So all this, what you see right here, is just a formal way of describing stuff. All right. And this formula you see right here, it's the same for sine. All right. So the amplitude is usually looking for the highest point in the graph. The period, you're going to, wherever you find, you're going to, divide by 2 pi. See if it's a negative direction, which means that it's going to, if it's negative, it moves right. You should divide that by b. But you really don't have to worry about the phase shift like that. And then the midline, it's just cutting the graph in half, but you don't have to worry about that. And then the vertical shift is when the graph moves up and down, which is d. And this is just no way of me writing all that. But that period 2 pi over b, that's something that you gonna have to know about, but I have a better way of explaining that. Alright, so the plot of cosine, this is what the cosine graph looks like. Cosine is just like sine, but it starts off at 1 and heads down until it hits pi, or 180 degrees, and then it has up a grid. So remember when I asked you the question about cosine being 0, if cosine is 0, that means the value is going to be 1. Because cosine 0 always starts off at 1. And the only time it's going to be 1 again, meaning that it's going to be negative 1, is when you are at 180. So cosine of 180 is going to be negative 1. So those are the only 2 times where cosine going to have a value of something of 1, either positive or negative 1. And again, this is just using knowledge of the unit circle. I'll clean it up because I know some of you guys like, Mr. Howard, that is bad handwriting. There you are. Alright, so here's the graph about cosine. And remember I was telling you about the period, about how the definition does suck? So here's how I define it. So a period is based on how many times something repeats from 0 till whenever positive value it goes to. So here, you see that this graph also deals with negative numbers too, but you're not worried about the negatives. You're worried about what starts off at 0, because that's what the unit circle starts off at. So, if I was to ask you the period of cosine, how many times does it repeat? Well, I mean starting from the value of 0. So it only repeats once, and it repeats when it gets to the value of 2 pi. Another way of doing that, if you didn't have 2 pi telling you that, that's where it repeats from the value. You could just go 2 pi divided by how many times it repeat, which is once, and you're going to get just 2 pi. And that's if you didn't have 2 pi telling you that. So again, you always start at 0. Always start at 0. And you're looking for that here repeating. So if it starts at positive, which that's what it starts at, when does it repeat again? At positive. It repeats again at 2 pi. So with that being said, take a moment and try to figure this out. Fill that table out on your own. Do the best you can. Pause the video. By now I have taken that you did watch, that you paused the video, you worked the problems out. So let's do it. So the domain of cosine function is going to be from negative infinity to positive infinity, which we knew because it's a periodic function. The graph never stops, it keeps going. So let's look at the range. The range is going to be from negative 1 to positive 1. And yes, it's going to be the same thing for cosine too. I mean for sine as well. So sine and cosine are going to have the same domain and range. So the period, we just did that. I told you that the period was going to be just 2 pi. The amplitude. The amplitude is 1, so let me explain where that comes from. So, draw your line from 0 and look for your high points. All your high points touch is when y equals 1. So because of that, your amplitude is 1. So figure amplitude is the highest y value. And you figure period in terms of repetition among the x value. The midline is basically saying when can they split in half. So in detail, you see how it's positive 1 here and it's negative 1 right here. Well, if you draw a halfway line to split that up, it's going to be at 0, because 0 is the halfway split. And that's essentially just that. Alright, another way of looking at this, if you know frequency, and frequency is how many times this repeats. So look at this graph. So it starts off at 1, and we're looking for when it hits the y value of 1. So 1, 2, 3, 4. So the frequency is 4. But the period of this is going to be 1/2. Because for every half value, 1/4, sorry. 1/4, forgive me. For every 1/4 value, that's what happens. So you got 2.5, and then at 5, it repeats, and then 7.5, and then at 1. So that's where that comes from. All right. And that's just another way of doing it if you wanted to do that. But sometimes this does not always work because of the whole 2 pi divided by b. You have to keep that in mind. So, but I'll tell you when to worry about 2 pi over b for the period and when not to worry about it. Because you look at your graph, it tells you when it repeats. It repeated every 1/4 value. All right. So this is just a formula that just tells you what goes where. So pause and just take notes of it. This is a sine graph, very similar to cosine, except for there's one difference that I was wondering who's going to point it out to me. All right. So look at these graphs carefully and let's compare. So you pause the video and figure out what's the difference between the two. All right. I assume that you pause the video, you figure out the two. If you say that sine is odd, symmetry, which it is, and cosine is even, you are to be correct. You are right. All right. I want you to try these out on your own. Go ahead, give me what we just learned about the trig functions, and let's just keep going. So you do this on your own. I'm not looking to reveal the answers to you. I will reveal some type of answer to you in next class period. I want to see what you could do on your own. I'm looking for your resourcefulness. Of course, these kind of problems I put on here, you can go online and find the answers to them. But I want to see what you could do on your own first. Alright, sinusoidal functions. It's just another word saying periodic. So, this problem uses some applications like heartbeats and throwing balls and stuff like this. However, I'm dealing with a harmonic motion. So harmonic motion is just throwing the ball and letting it bounce up and down, up and down. So a ball on a spring is pulled 4 inches below its rest position and then released. The period of the function, of the motion is 6 seconds. You have to write the equation for the ball's simple harmonic motion. How are you going to do something like that? Well, it's always good that you have pictures. So that's a picture of us pulling it down and a picture of what's going to happen when you let it go, bouncing up and down. Now, I want you to help me figure this out. Do you think this is going to be a cosine function or a sine function? That's what we got to know first. Well, I'll be honest with you. You want to start off saying it to be a cosine function, not sine, because you lowering the ball. So when you lowering it, and you look at your cosine graph, you realize that you are at a point because like cosine starts off at 1, and then as you go through it bounces to -1, come back to +1, and etc. So this bar, when we pull it, is lowering itself to a -4. So by then, we know a couple of things already. And you don't need this information. This is not needed. So we know there is a cosine function. And we also know that our amplitude, which is going to be A, is going to be -4. Now we got to figure out our period. And the best way for us to know our period is us using the formula 2 pi over b, which is 6. But we know to get b, you have to multiply both sides by b, and you get 2 pi equals 6b. Now, the question is how you going to get b by itself. So, of course, we divide it by 6, and we get pi over a third to be b. Now, this is the part where you gotta figure out that little detail. I'm not gonna explain the detail, that's for you to figure out. Now, with that being said, the period being pi over 3, you can put everything together. And once you put everything together, guess what? You got your equation. Now, you try doing this problem yourself. Same methods, no tricks, no surprises. And guess what? You have finished the last lesson for the semester. Hooray! Kudos! You have did it. Homework for the remainder of the semester is going to be cool. Unfortunately, because we don't have copier, I have to reserve my paper copies.